All right, let's take a look at some examples of solving systems of equations. In this example here, we have 4 variables, 4 equations, 4 unknowns. Let's go ahead and do that. So as discussed in the lesson, you want to go ahead and put this in a matrix. So I'm going to go ahead and put this into a matrix. When you copy this into a matrix, assuming these are in the correct order, so W, X, Y, Z, that's how we're sort of viewing these. You just copy the coefficients down in front. So in this case, this will be 1, 2, minus 1, 1. Put this line down here to make this an augmented matrix. That indicates we have the end of your variables. You're equating that to 6. Same thing with the next one here. This will be 2, 3, 1, minus 1, 7, negative 1, 1, 2, 3, 19, and 3, 1, negative 2, 1, and 3. So now that I've gone ahead and transformed this all into matrix form, we can focus on row reducing this in such a way that at the end of this, we want all of these entries below, all of these ones you see here, I want these all to be 0. And when you do that, your matrix is said to be in upper triangular form, and we can use back substitution to go ahead and solve this here. Now you'll notice here, when I'm going to go ahead and solve this, I've got a 1 in the top left-hand corner here, and this is ideal if you can get it in there. So you can always interchange your equations to get a 1 in the top left-hand corner. But at any rate, like we discussed, I want to make all of these 0 first. So to do that, I'm going to take row 2 and subtract twice row 1. By doing so, that'll make this entry a 0. For the next entry, right here, I want to make this a 0. I'm going to go ahead and take row 3 and add it to row 1. And lastly, for this entry here, I'm going to take row 4, and I'm going to subtract 3 times row 1. And when we do that, we get the following. You can notice here that the first row I'm not touching, so I'm going to write it back down just as it is. All right, continue on here. Now I've got row 2 minus twice row 1. So doing so here, we get an entry of 0. Now I'm going to get 3 minus 4 is negative 1. I'll get the next entry is going to be 1 plus 2, gives me a 3. The next entry here is going to be negative 1 minus 2 is negative 3. And lastly here, you're going to get here 7 minus 12 is negative 5. Continuing on here, for the next row, we're going to add row 3 and 1 together. It's going to give me 0, 3, 1, 4, and 25. And then lastly, for row 4, we're going to take row 4 minus 3 times row 1. That's going to give me a 0 for my first entry. Then I'm going to get 1 minus 6 is negative 5. Negative 2 plus 3 is 1. 1 minus 3 is negative 2. And 3 minus 18 is negative 15. Okay, continuing up here, when I go, now again, my goal here is I want to go ahead and make these entries a 0. Once you get this column of zeros and you move on to your next column of focus here, you're going to change your anchor, right? This is sort of my reference point was row 1. I'm going to move my reference point to row 2. And the reason for that is, like in this situation here, if I want to make this a 0, I'm going to go row 3 plus 3 times row 2. If I had, for whatever reason, referenced row 1 here, I would end up bringing an entry down into this row, and it would actually knock me back further than when I had started. So whenever you switch, when you finish making zeros in one specific column, you move to the next, your new reference point is going to be with respect to row 2, and you usually reference this value here. So I'm going to do row 3 plus 3 times row 2, and then we're going to go ahead and do row 4 minus 5 times row 2. So the first row is untouched. The second row is also untouched. And the third row is going to be 0, 0. Now I'm going to have a 1 plus 9 is going to give me a 10. I'm going to have a 4 minus 9 is going to give me negative 5. And then lastly, in this case here, we get 25 minus 15 gives me a 10. Continuing on here, for row 4 minus 5 times row 2, we get a 0, another 0. This ends up being, here I'm going to have here 1 minus 15 is negative 14. And then I'm going to have negative 2 plus 15 is going to give me 13 here. And then lastly, we're going to have negative 15 plus 25 gives me 10. All right, let's continue on here. So making our way along with this here and continuing this up here, I want to go ahead and now shift my anchor to row 3. And I just want to make this entry here a 0. A little bit of math involved with this. I'm going to take 10 times row 4 and add that to 14 times row 3. You might make the observation here, we can reduce this row. If you wanted to, you can do this and it'll work, but if for whatever reason you wanted to reduce this, I can go ahead and multiply by a 5th row 3, and that's the notation that you would use to illustrate that if I wanted to reduce. So, and we can do that, make the math a little bit easier. But what I had originally written down will work as well. So now going ahead and dividing across by a 5th, we end up getting 0, 0, 2, negative 1, 2, and then this row we leave unchanged here. And then I'm going to go ahead and make this entry 0, so I'm going to take row 4 plus 7 times row 3. And doing so, the first row is good. The second row is also good. The third row. And going ahead and doing our last row here, we're going to get 0, 0. In this case here, also, as intended, we get a 0. And for this here, it's going to be 13 minus 7. And 13 minus 7 is 6. And then lastly, we have here 10 plus 14. And 10 plus 14 is 24. So now you can see here, I've row reduced my matrix. It is now upper triangular. Now that we've done that, I can go ahead and solve the following system. So we can quickly unravel this here. You can see here, keeping in mind that these columns have placeholders. This is my W, this is my X, this is my Y, this is my Z, this is my equal sign, and these are my numbers. This equation right here tells me that 6Z is 24, which implies that Z is 4. Moving up, and that's why they call this back substitution, we substitute into my second from the bottom row here. We end up getting 2y minus z is equal to 2. I now know the value of z. I know the value of z is 4. So solving for this, you end up getting here that y equals 3. Now I know, if you can see here, I now know the value of z. I know the value of y. I can now substitute both of those into my second equation from the top here. And this ends up being negative x plus 3y minus 3z is negative 5. And negative x is what we want to solve for. I know the y value is 3. I know the z value is 4. And I'm just a matter of solving for this here. This becomes negative x plus 9 minus 12 is negative 5. End up getting here negative x is going to be negative 5 plus 3, and solving here, you end up getting here that x is 2. So now I know my z, my y, and my x, and just to finish this off, we can go ahead and focus our attention on this first row, and this ends up being w. It'll be plus 2x, but I know the value of x is 2. Minus y, I know the value of y is 3, and then plus z, I know the value of z is 4, and that has to equal 6, in which case I get w plus 4 minus 3 plus 4 is 6, and we end up getting here w is going to end up equaling 1. So solving for this here, using our w, x, y, and z, I get the point of intersection, and there is only one here. The point of intersection for this system is 1, 2, 3, and 4. All right, thank you.